Good afternoon. Thank you for joining me today in what is one of the last sessions here at Coalesce. Hope everyone had a great conference. Today I'm going to take you through our DBT data migration journey and essentially go through some best practices we found for migrating large-scale projects. Who am I? My name is Jean-Paul Azzopardi. I'm a data analytics engineer at Tatango. Today I'll share how we transformed our data stack using Snowflake and DBT to unlock AI messaging at scale. This is a journey from bottlenecks through breakthroughs, and I'll walk you through the problem, our approach, and impact it had. So just before we kick things off, what is Tatango? As you can see on my shirt here, we work for Tatango. I'm here with my colleagues Tommy and Dakota. Special shout out to them. Tatango is a messaging platform built specifically for non-profit fundraising. Every year, we power billions of text messages that help organizations connect with their supporters, inspire action, and raise critical funds. Our mission is simple: help nonprofits raise more money with less effort through messaging at massive scale. So what is the agenda for today? Today, we're going to look at how our legacy infrastructure posed a bottleneck for implementing AI-powered workflows. We're going to then see how this manifested in which manifested in advanced personalization features were practically impossible for us to implement with our existing architecture. We'll then look at how we migrated data warehouses and DBT models and the best practices we found most useful for doing so. We'll look at the impact on the business, and then we'll look at how Tatango is moving forward with AI messaging, and then I'll take any questions if we have time. All right, so getting started. Basically, our legacy infrastructure was holding us back. We were on a single Redshift cluster. We were hitting query performance ceilings, struggling to adopt AI models, and our developer velocity slowed dramatically. Redshift became a bottleneck from preventing us from reaching our full potential, especially when it came to AI personalized messaging campaigns and real-time ROI evaluation. So we were stuck in this place where we couldn't implement these AI workflows that we wanted to, and we were thinking, okay, how can we move forward and get past this and have our DBT models run in an efficient manner that we wanted it to. Our data bottleneck manifested in several ways. We had query performance constraints. Critical messaging campaigns required time-sensitive data processing that repeatedly hit performance ceilings, limiting our ability to scale. We couldn't adopt AI and ML models in our legacy infrastructure. And then our data models took hours instead of minutes to change and materialize, creating a backlog of enhancements and causing friction between teams. This wasn't just a technical pain. It had actual real business consequences. Campaigns were delayed because queries ran too slow. Personalization wasn't feasible with our architecture. And simple model change took hours, causing frustration across teams. So we decided to conduct a study to compare different warehouses in order to gauge how each would be able to handle our workload. This was done sometime last year. I published a study on this online on Medium if anyone is interested in exploring that further, although we won't go into depth about this today. So we ultimately decided that we wanted to move away from our legacy systems, and we decided to choose Snowflake and DBT moving forward. Why Snowflake? Well, we liked its native Cortex AI capabilities for advanced text personalization, its elastic compute scaling during high-volume messaging periods, and the secure partner integrations. DBT was critical for us, mainly because of its version control, modularity, and testing. We have over 1,000 models test at macros at Tatango in our DBT repo, so it's critical for us to make sure that we migrate our DBT models in an efficient and good manner when switching from Redshift to Snowflake. And our migration approach was staged. We had 4 different stages of our approach. We wanted to create parallel environments where we could run Redshift syntax and Snowflake syntax for our DBT repo. We wanted to validate and test all our DBT models to make sure that data between Redshift and Snowflake was accurate and we had good data integrity. We did historical backfills for all our models as well. Once we shifted over data warehouse, and we did a cut over and optimization of our models in Snowflake once that was done. This is a timeline of how long it took us to complete this project. Here it's about 5 months. I'll get into more details about it later on. But essentially, we started with establishing parallel dbt environments. We did validation and testing in March. In May, we did our backfills. And then by June, we cut over and optimized. So if we boil it down to just 3 points, our solution was threefold. First, create dual dbt environments to run on both Redshift and Snowflake. Second, migrate and validate over 1,000 models, macros, and tests with strong data integrity checks. And third, perform a careful switch over and optimize for Snowflake's architecture. So how did we execute the plan? I'm going to go into some details here of our dbt dual execution and how we built custom macros that let a single code base compile correctly on both Redshift and Snowflake. This dual execution was a lifesaver. It kept the business running while we migrated. It also meant that we didn't have to go through the laborious process of changing syntax for each and every one of our 1,000 models. With the help of macros, we were able to blast through our models and ensure compatibility with both Redshift and Snowflake throughout the migration process. So just to give you a bit of an example, on the very right-hand side, we have a macro called migration sysstate. It's essentially a simple if-else statement. And if it connects to the dbt environment that is Snowflake, it would use the function appropriate for Snowflake, which is sysstate with parentheses, whereas in Redshift, it would just be sysstate. Simple macro and a simple explanation of how we can create custom macros that will compile for both Redshift and Snowflake. A caveat to this, I guess, is the fact that dbt Fusion is now has been launched and is warehouse agnostic and SQL agnostic, but that's not in GA yet. So this approach, I think, works well still nowadays. So yeah, simple if-else statement. If it connects to the Snowflake environment, it uses one set of functions, and then if it connects to the Redshift environment, it uses a different set of functions. This is more of a complex example on the left-hand side. Basically the same idea, though, if-else, a big if-else statement. This is for our migration source macro, so it replaces the source macro that you would use in dbt with just a migration source macro. And in our old Redshift tables, we prefixed everything with source Tatango or Postgres source, but we did some string manipulation in our macro, removed those prefixes. Otherwise, it evaluates to Redshift if it's connected to the Redshift environment and uses the standard source macro. Does that make sense? Yeah, perfect. All right. So just to give it a bit more of an example of how the workflow showed itself, the macro determines which environment we're using. It's a simple flag. When we run dbt run, we flag which environment we're using. It then returns the specific SQL, whether it's Redshift or Snowflake. Again, a bit of a lifesaver because it avoided us having to refactor all our models. We could just search through them all and replace our source macro with migration source, our sysstate with migration sysstate, and there were many other macros that we use as well. Here's more of an example of how you would use this in an actual dbt model. You can see the top here. We have the migration source macro replacing our normal source macro. Same with the bottom here, a migration source macro, and we have the migration sysstate as well. So again, it showed us just how we're able to execute dual environments in our repo without having to refactor all our models and create different models for Snowflake and Redshift, et cetera, et cetera. All right, so the next step was, once we established a dual execution environment, the next step was ensuring that what we had running in Snowflake matched what we had running on Redshift. It's extremely time-consuming to generate validation configurations by hand, especially when you have over 1,000 models and tests like we do. So what we did was implement a new CLI tool to handle the generation, test execution, and results summarization. And what we came across was Google's data validation tool, which helped us ensure trust. It's basically an open source Python CLI, that provides an automated and repeatable solutions for validating across different environments. And it's really simple to implement as well. It's a YAML file where you define your source tables. In this case, we're looking at account balance changes, which exists in Redshift. And then you define your target tables, which exists in your other data warehouse or other environment, different environment. And then you just define all your columns, and the data types as well, and the aggregation type that you want to evaluate for. So what it essentially does is it will look at, for example, old balance. It will do a sum of old balances in one table, a sum of old balances in the new table, compare those numbers. If it matches, then the data test pass. If it doesn't match, then it will fail. I'll explain this a bit more in the next slide. I know this can look a bit overwhelming, but I'll try to break it up for you guys and show you how dbt exactly works. It supports a lot of customizations when validating your data. You can validate multiple tables, run validations on specific columns, and add labels to your validations. So this is an example of how we ran dbt. At first, it connects to our Redshift database. Then it connects to our Snowflake database. It then produces a sum validation for the specific table. In this case, we're looking at account types. And then what it simply does is generate SQL both in Redshift and Snowflake and compares the aggregations between the two tables and produces a sum validation table, a summary basically of what it analyzed, what table it analyzed, what columns were analyzed, the aggregation type, the source values, target values, and the difference between the two as a percentage. And you can also set an error threshold as well in dbt. So if you have some leniency in terms of how you want your data integrity to be, you can also set an error threshold. And in this case, we see that the difference here is 0%, so this test passed. And then we run this essentially for all our models, and if there's any discrepancies, then we can dig deeper ourselves and see exactly where the discrepancies are between both data warehouses. All right, so as a byproduct of the migration, we were able to optimize our models significantly. Our core messages model, which powers a lot of downstream applications and BI tools, et cetera, dropped from 5 minutes to under 2 minutes. As you can see from the diagram here on your right, around June, when we did a cutover and optimization, our main model dropped from, roughly 5 minutes to around less than 2 minutes. The whole pipeline used to take around 7 minutes to run, but now it runs in under less than 2 minutes. So we were able to optimize significantly, which helped reduce our costs as well for model runtimes. Then the next step was figuring out how are we going to tear down all this legacy infrastructure that we set up. So we have our dbt dual environment where we have these macros already established. And now we need to take those macros out and just shift completely to Snowflake and remove anything we had that we set up for the migration. And this can be another tedious task that can take forever to do if we didn't have the help of AI. We thought to ourselves, how can we use AI to help speed up our workflows? And engineers at Tatango kind of developed a pipeline using both Corey AI and Devin AI to help with more tedious tasks, including removing legacy code from our code base. Devin AI is not great at a lot of things, I'm aware, but it does help us clean up technical debt. And if you don't know what Devin AI is, it's basically just like a software engineering program or agent, and it's designed to handle various tasks, including coding, debugging, and even building applications. Corey AI is just an AI-powered project management agent, which we use to create tickets in Shortcut. And combining the two of them allowed us to create tickets in Shortcut. We tell basically Corey AI, hey, we want to remove Redshift from our dbt code base. We give it certain prompts and say, this is important to do. Anything commented or deprecated, please remove. It generates a ticket for us, and with that ticket, we can assign it to Devon AI, which basically acts as a junior engineer and removes the DBT removes Redshift code from our DBT code base and creates a PR for us that we evaluate ourselves and merge. Obviously, you need a lot of oversight when using these tools, but it definitely sped up our process a lot. In fact, it sped up our whole migration timeline by a month. So we were expecting to finish by July, but with the help of AI tools, we were done by mid-June. So yeah, AI accelerated our migration by a full month, which was great. All right, retrospective, looking forward, the results really speak for themselves. Queries have now run 68% faster, developer velocity tripled, and personalized messages are driving higher engagement. These outcomes really did make a measurable difference for our nonprofit partners, which was great. And what are some of the key learnings we took away from our DBT migration? Well, we said something that's very important for us is to treat DBT like an application. So implement thorough testing, CI/CD processes, and validating frameworks across cloud platforms. We found that our data models are critical infrastructure, so we like to treat them accordingly. We saw firsthand as well just the power of AI tools in speeding up work by using both Coalesce AI and Devon AI to help us tear down legacy infrastructure. And we realized that models that had great documentation were much easier to migrate and validate than poorly documented ones. So make sure you document all your models, especially models that we had legacy models we had from previous engineers who had left, and we need to figure out exactly what this model did. So definitely invest in documentation when doing stuff like this. So looking ahead, Tatango is using its new AI capabilities to implement some pretty cool stuff. We think this is the future of SMS marketing. I'll explain something in a bit, but what we're doing is dynamic segmentation, real-time support categorization based on engagement patterns and donation history, hyper-personalization with our AI-generated message variations, instant ROI analysis, and predictive modeling, where we can anticipate when a customer is most likely willing to donate and send a message at that specific time. AI, we believe, will continue to shape how nonprofits connect with the supporters, and this wouldn't have been something possible without the migration we did in DBT. So an example of how this manifests nowadays is with the use of power segments. This is something we were able to segment our customers based on affinity levels, basically, which helps you prioritize highly engaged supporters first, or focus on re-engaging on those whose activity is declining. So we can able to segment our customers and send messages based on whether they're considered to be champions, highly engaged, passive constituents, at risk, inactive, and so on and so forth. So a very cool feature that we're really proud of implementing, and our customers love it and are able to send it to clients based on affinity level, which is great. And with that, that brings me to the end of the presentation. Thank you very much, and I think there's time for questions.
You mentioned about the documentation. There were some models which didn't have a documentation. So how did you generate? Did you use DBT to generate the documentation for them, or did you analyze and try to write it on your own?
Yeah, we had to track it on our own. So the question for those who couldn't hear is, when it came to documentation, how did you use DBT to generate the documentation, or did you have to track it on your own for the specific models? And considering that it was important for us to understand how the models worked on a personal level, just because we were migrating, those models were still in use and important to us regardless. So we had to really just dig deep ourselves and understand what a model does. And we didn't use DBT to generate it. We just did it ourselves. Yeah.
Was it one team that was largely responsible for a lot of this how they work with the data, but for cost?
Yeah, good question. So I didn't touch upon this, but Tatango is quite a small company, and our engineering team is comprised, I think, of maybe like 15 people in total. Our data team is just me and someone else. Although the project was just five months from January to June, we really started thinking about this middle of last year, conducting studies and trying to find which is the best solution for us. So we did have help from others, but primarily it was between me and another engineer working on this pretty extensively for the 5-month period. Yep.
I'm curious about the data validation step. Once you have the 2 pipelines running, what kinds of errors do you see, or what kinds of differences do you see, and did they generally come from like changes you had made, or were they something that you maybe didn't expect to see?
Yeah, there were, luckily we didn't have many errors, but it could have been stuff like different data types, errors with different data types between one or the other. Some minor variations and issues with our source data as well that caused certain errors. I'm trying to think off the top of my head what other errors we experienced, but for the most part, it was pretty successful. It could have just been a matter of source freshness as well between the two that resulted in errors. You're welcome. Yeah.
I had a question about the documentation of legacy models. If you ran into any complicated legacy models and how you might have resolved those conflicts with documenting them.
With documenting them? Yeah, so the question was about how we resolved documenting legacy models. Really, it was just a matter of digging deep and just understanding each model and looking at lineage, for example, of that model in cloud and understanding exactly where it comes from. Thankfully, we've been there a few years now where we've got a good understanding of most of the models, and most of the models were created by us. But with the legacy models, it was definitely a matter of just going through the SQL bit by bit. Checking the table, checking the lineage, and then there were some models that we found that were just like not being used at all. And then once we realized that, we would remove those models in general. But yeah. Yeah, go ahead.
When you were in Redshift, was DBT your ELT tool as well, or you had to migrate from something else into DBT?
No, DBT was our ELT tool as well. Yeah, we wanted to stick with DBT throughout. It's a core tool for us in our data migration, data platform. The matter was trying to figure out how were we going to have business continuity as we're moving from Redshift to Snowflake, because DBT powers a lot of our BI tools. So that whole idea was how can we create parallel environments where we're shifting things over to Snowflake, but still working with Redshift in production, with our DBT models in production, and make sure that we're able to just switch over in a timely manner and make sure everything was accurate as we were doing it. Any other questions?
What was the volume of your data size?
The size? Well, we deal with, I don't know the size off the top of my head, but we have some tables that are billions of rows. Our main messaging platform table is in billions of rows. I don't know the exact size of it, but yeah, some of it had to just be dumped into S3 as well and put into I think it's called S3 Iceberg. But yeah. Anyone else? Yeah.
Did you create any pre-production or development environment for the Snowflake as well?
We did, yeah. We did for testing, but I don't think we used it much between the migration, just because it was a completely new environment for us in production in Snowflake. So we set it up from scratch, and none of the we didn't cut over completely until all the migration was done and all the checks were done. Yeah. Yeah.
So since you coupled both Redshift
Yeah.
Right? How did your observability look? Let's say Snowflake got failed for whatever reason because you're still doing the testing. Would it ever impact your Redshift codes?
I didn't quite understand the question.
You have the same model running
Yeah.
for both the Redshift and
Right.
Snowflake, right? Since Snowflake is still in kind of non-production,
Yeah.
Redshift is still production.
Yeah.
While you're still testing and rewriting your models for Snowflake, if it fails, did it ever impact your production on the Redshift side?
No, no. Just because the fact that we were trying to make it SQL agnostic by having different functions. So we would run it with a flag for different environments. So the environments weren't touching each other at all. They were just running in parallel. Yep.
For this 5-month period when you were working on it, were you also supporting like business as usual? Or was
Yeah.
this most of what you were?
No, I mean, we were supporting business as usual. So we could have condensed that time frame further, but we're a small team, so we have a lot of different requirements throughout. And plus, we wanted to take our time with this. We had no real rush to get this done. We wanted to make sure we did it properly. We didn't want to cut over and then shut down our Redshift cluster and have data issues in Snowflake. So we really took our time with this. But we felt like we could have done it quicker. But again, we're a small team of just 2 engineers on the data side. So yeah. All right. Thank you very much. Enjoy the rest of your day.